of course close, not only close but also lies at the initial point. So here P is equals to 0. So we have derived the formulas for first order, second order and third order so far. So we'll be writing the formulas first. The formula for the derivative is, if you remember, dy over dx for the first order derivative, and this was equals to 1 over h inside delta y0 minus 1 by 2 delta 2y0 plus 1 by 3 delta 3y0 minus 1 by 4 and delta 4y0 and so on. So this is the formula which I didn't write actually, but I told you you can create this formula just by putting p into the first order derivative we derive by keeping p equals to 0, because p is here 0, so no more p will be including into this formula. So in order to start this formula, we require these informations of deltas. As you know that while studying the interpolation, we have also find out the values of these deltas by constructing a difference table. So here we shall be constructing the same kind of difference table. So here we are given the values of x, y, and these are, you can count that there are 6 points. So we can go up to the fifth order difference. So this is delta y0, delta 2y0, delta 3, and delta 4, and we can go up to delta 5. So this is the title or heads under which we have to fit the values. So the corresponding values are 1.5, 2, 2.5, 3, 3.5, and 4. And the corresponding values of y are 3.375, 7, 13.625, 24, 38.875, and 59. And now we do the same step as we have been doing while studying the interpolation cases. On taking the differences, the result takes the form 3.625, 6.625, and next is 10.375 and 14.875 and 20.125. And the second order difference can be obtained by taking the difference of the two consecutive terms. So here we get 3.75 and 4.5 and 5.25. And the next order differences will be obtained 0.75, 0.75, 0.75, and the remaining will all be 0. So this makes a bit easier for you. Okay, the second, fourth and the fifth order differences are 0. So we have to write down the formula for the derivatives, which is written here. So we have to move up to only the third order up to here. Now the values, as I told you, because we have to measure the rate of change at this point, so we will be placing ourselves here. We are taking start in the values which we have to use and just putting them in the box. These are the values we have to use, and remaining are 0, so there is no need to put them into the box. So these are the values. We have to separate them to find out the first order derivative. So here let me write down the corresponding value which we have to use. Y0 is equals to 3.375. This is the value which I have to use. Second, delta Y0 3.625, and delta 2Y0 is 3, and delta 3Y0 is 0.75. So this is the these are the values which we have to use for this formula. So the formula is still on the board. You have to just put in the values which I have separated them into this formula. So the result takes form dy over dx is equals to 1 over h. H is the common difference. You can obtain very easily. You can see 0.5 is the difference. So here we write down 1 over 0.5 means 1 over 0.5. Inside this gives you y is delta y0. Delta y0 is 3.625 minus 1 by 2. Delta 2y0 is 3 plus 1 by 3, and delta 3y0 is 0.75. So this is very simple, and no more terms are there. You have to use now your calculating devices, and on simplifying this, the result becomes equals to 4.75. So here you see, okay, no functions are given to you. You are provided only the set of points, and we find out the rate of change by using the interpolations formula, and this is the derivatives formula which we have used. Similarly, if you are asked to use the to find the second order derivatives or the higher order, third order derivatives, so we have the option in order to find out the second and higher order derivatives. So for this you have to write down first of all the formulas for the second and the third order derivatives. So here we are interested in to calculate the second order derivative. So the formula for the second order derivative is d2y over dx square is equals to 1 over h square. Inside there will be delta 2y0 minus delta 3y0 plus 11 by 12 delta 4y0, and many more terms can be there, but we restrict ourselves up to this level because we can go up to the third order in this case particularly. So this is the second order derivative formula which we have derived, and there we have put in p equals to 0, so we obtain this result. Now bring the values inside. So this gives you 0.5 square, delta 2y is 3, and delta 3y is 0.75. So it's a very simple calculations, and on simplifying by using your calculators you will be getting the result is equals to 9. This is the second order. Similarly for the third order, if you are required to find out the third order derivatives, so here we have the formula for the third order which we have just derived, and the formula is delta 3y0 and minus 3 by 2 times delta 4y0 and so on, because we have to use only this term due to this reason. And now we have 0.5 whole cube outside, inside this will be 0.75, and on simplifying the result is equals to 6. So we obtain the first order derivative is equals to 4.75, second order is 9, and the third order is 6. So far we have been using only the the forward difference interpolation formula, and we obtain the 3 different derivatives by using it. A similar kind of 6 more formulas can be written down for the backward interpolation formula, and you can perform all these steps of yourself very easily to write down not only the backward difference formulas, beside this you can also use them to solve the problems. So here we write down the formulas directly without giving the proof for the backward difference, because backward difference formulas are used where we have to look at the values lying close to the endpoints. So the value we are looking in this case is lying close to the starting point, that's why we use the forward difference. But whenever a value you are looking for the close to the endpoints, so there you have to use the backward difference interpolation formula. And one more thing you have to note down, here we have used a formula doesn't contain any p, because we are looking the value is lying on the point which we have used to calculate the p. If it is other than p, so there will be p there, okay? It will not always be the case the p is getting equals to 0. So this should be clear in your mind. Okay, let's write down the formulas for the Newton's backward difference interpolation. So derivatives formula derivatives formula for the Newton's backward interpolation formula. So for the backward interpolation formula, the first derivative formula is